Hello my friends, and welcome back to the signal state. We are going to jump right back in here with, where were we? Logic test is up next. And we're going to be doing this one a little bit different. Previously, I've been doing a separate episode for each level. But what I'm noticing is those aren't getting a lot of traction. People aren't seeing them. And I'm not sure if that's because people just aren't interested in the series, which would be totally fine, or if it's because they are significantly shorter than the other content on my channel. Typically, these episodes have been ranging in the like 3 to 10 minute range, where everything else on my channel is usually in the 20 to 40 minute range. So we're going to do this one a little bit differently. I'm going to play potentially multiple levels to try and get up to that kind of standard content length duration, and we'll see how that goes. And you know, as ever, hit the like button if you like this content. Leave some comments. That lets me know you're interested, and if you're not, then you're not, and that's cool, and then we can move on to a different series, whatever. But right now, not really sure why there isn't much engagement, so trying to just get a feel for that. So with that, let's jump right in here to logic test. Excellent. Now that the firmware program is working, we can get the logic modules working and give them a test. Sure, let's do it. All right, our objective this time. If source 1 and source 2 are both 100 volts, send 100 volts to out 1. Otherwise, send 0 volts to out 1. You know what? Let's just jump right in here. Let's get in and work on this. We'll do this in real time. All right. Do we have show module catalog? Do I have anything new? Oh, look at this. I have ors, ands, and nots. Okay. If either input is more than 0, 100 is output. That's interesting. These work specifically. If both inputs are more than 0, 100 is output. It's interesting that they're locked to 100 and not an input amount, but that's fine. We can work with that. So if 1 and 2 are both 100, send 100 to out 1. We can do that. Let's start with a splitter. And I'm actually going to start with 2 splitters to give us a bit more flexibility to reuse both sources. All right, so let's look at the first scenario. Yeah, we have 2 sources and 3 outputs. So if 1 and 2 are both 100, if both inputs are more than 100, no, if both inputs are more than 0, then 100 is output. If 1 and 2 are both 100, is it always that way? Okay, yeah, so these input lines are always either 0 or 100. Okay, we can work with that. So then source 1 is going to be an and. So we're going to say if 1 is more than 0, which in our case is 100, and 2 is more than 0, which in our case is 100. If they're both 100, output 100. That should be the first output. All right, let's go ahead and test that. Okay, it was super mad because of output 2 and 3. Can I just like, it'd be cool if I could like disable these so that I could just hear the tracks one by one. I don't know what that is, but that's fine. Oh, maybe is that length in real time? Oh, it is. That's cool. I don't really care about length though. Record, hands, pause, lock controls, lock cables, lock modules. Cool. Okay, so we can see that at least up to this point, out 1 is just fine. So we're good on out 1. Now let's take a look at out 2. If source 1 and or source 2 are at 100, send 100 to out 2, otherwise send 0. I think in that case we just want an or, right? If either input are more than 0, which in our case will be 100, then output 0. Yeah, so I think we just use an OR. We say 1 goes in, 2 goes in, and that comes out. Let's give that a shot. Yep, okay, so out 1 and out 2 look good. Now let's look at out 3. If source 1 and source 2 are both 0, send 100. Otherwise, send 0. Okay. If they are both 0, then send 100. Now that's interesting. If the input is more than 100, is more than 0, send 0. Right. Okay. So I think what we want to do, if source 1 and source 2 are both 0, so if not 1 and not 2. So I'm thinking back to my college days, thinking back to my computer science, my discrete math courses. One of the things you can do with on-off or Boolean logic like this is you can invert it. So for example, if you have, let's say, 1 and 2, if you want to negate that, you can negate, that is equivalent to the inverse of the opposite. What does that mean? So like 1 and 2 is the same logically as not 1 or not 2. Is that right? Because if you have 1 and 2, they're both high. If I'm thinking in terms of this, they're both high. But the inverse is going to be if 1 is low or 2 is low. Which, if 1 is low or 2 is low, obviously they're not both high. And because it's ORing them, if either one of them or both of them is low, it doesn't count. So yeah, those are equivalent statements, I think. That was, I feel like I explained that very poorly. Maybe if you're interested and you want me to kind of clarify how I worked through that, let me know in the comments, and I can like make a episode kind of explaining Boolean logic, because I think for this series in particular, that's going to be the bulk of what most of these puzzles are going to be. So okay, so knowing we can do that, if we need, so we need not 1 and not 2, so we can invert that. Right? And say not 1 or 2. How would I do that? Or 1 or 2, not. So what is this going to do? This is going to say if 1 is low or 2 is low, or they're both low, output 100. Is that right? I think that's right. Let's try it. And there you have it. All right. Onward and upward. Logic modules are really powerful. You're not just doing basic math now. You can change how signals flow with logic. I think I know what you mean. In the interest of getting through these puzzles, I'm not really digging into a lot of the dialogue. It hasn't really seemed necessary. But as with anything, let me know in the comments if you'd like me to dig into all the dialogue. I'm more than happy to do so. min-max test. So here we're going to need min and max modules. Cool. And let's just get in here. All right. Min and max modules take two inputs and output the smaller and greater of the two input signals respectively. Source 1, source 2, and source 3 are random signals. Out 1 receives the greatest value and out 2 receives the smallest. Okay. So we have min and max here. So min is going to take two things in and give me the smaller of the two, and max is going to take two things in and give me the bigger of the two. So as with everything else, we're going to take a couple splits. I think we want 3 splits, one for each input, so we can do multiple stuff with them. Now, we need, of these 3, we need to find the smallest one. So we can do that pretty easy with 2 mins. We take the smallest of 1 and 2, and then compare that with 3, and take the smallest of those 2. And that'll give me the smallest, which needs to be out 2. And then we will do the exact same thing for maximum. We'll take the higher of 1 and 2, and then the higher of that, and 3, and that goes into out 1. There you have it. Very, very easy. All right, you got it. Anyway, enough hand-holding. Let's get complex. Let's do it. I'm ready. That's the spirit. Irrigation system. I trust Gordon has done his job well. You should be decently familiar with how VCAs and logic modules work now. Yeah, I think so. Good. We can now move on to the next step. We need to prepare the crop fields for planting. This will require a functioning irrigation system. How do we fix that? The first component is the central pump. It provides a very precise rate of flow of water. You'll need to regulate the flow using the given control signals. Combine the concepts you've learned so far, VCA gating and logic. All right. Let's dig right in. We'll take a look at the requirements once we're inside. All right, there we go. So, when source 2 and source 3 are 100 volts, send source 1 to out 1. That should be easy enough. Let's start with a couple splitters. Now it looks like requirement 2 and 3. Oh, that one also needs source 1. Okay. So let's start with some splitters, as always. 1, 2, 3. Okay. Now, when 2 and 3 are at 100 volts, and these are always 100 or 0. So we are going to say when they are both at 100, that's an and. When 2 and 3 are both at 100, oh, send source 1 to out 1. Oh. Oh. So I need to pair that with a VCA. Percentage amount of the signal to send to the output. Yeah. Okay. And then we send 1 in here. So what is this doing? We're taking 2 and 3 and saying if they're both high, then send 1 to out. Oh, look at this. Oh, no. Oh, this just got way more complex. We have to send... We only have a single output. Oh, no. Okay. Okay. how does this work? I think this works by having a VCA for each of these. Can I like change the cable colors? I was hoping I could like add a comment or something on these. And I think we need to sum these together. Like this. So this will be this first one, which we already have set up. Right, and so what will this do? If 2 and 3 are 100 volts, it will send source 1 to out 1. Otherwise, it will send 0. So we need to make sure that this VCA is going to take the second requirement. This VCA is going to take the third requirement. And what we need to do is make sure that each VCA outputs 0 when that requirement is not valid. So we have the VCA1 set up, so it will send 100 when its requirement is met and 0 otherwise. Now we need to do the second one. So if either 2 or 3, but not both, are at 100, send the inverse of source 1 to out 1. Okay, let's think about this. And this fits with the logic I was saying before. So we need either 2 or 3, but not both. So what does that look like? That's... Actually, I think the third one might be easier. If both 2 and 3 are at 0, send 0. Hurt my brain a little bit. As we're getting into the part where I think I'm gonna have to start cutting out some thinking time in these videos. This just hit a big difficulty spike. Okay. If either 2 or 3, but not both. Okay. So we're gonna say if either 2 or 3. But not both. But not both. Oh, look at this. What is this? Oscilloscope. A 4-channel oscilloscope that will display the last 8 values for a given input signal. Used for debugging purposes only. That's interesting. So it's kind of like a mini version of this, except you can see what's actually on the line. That's cool. Okay. So here's what I've got. What is this doing? We're saying if either 2 or 3, but not both. So if we do this here, and we say 2 or 3, that's going to give us 2 or 3 and both. So then we want to subtract the both scenarios. So then we say, if it's 2 and 3, if it's 2 and 3, actually, I think we want to get rid of this not. We take the 2 and 3 scenario, we subtract it, or we take the minus of it, and then we sum those together. So if it's 2 or 3, this will be 0, I think. And if it's 2 and 3, this will be 100, and then we can say 100 minus 100 is 0. I think that's what we want. And that goes into our second VCA. And And then we need the inverse of source 1. So that will be an attenuator at minus 100. Source 1 is what we output. No, wait, I have these reversed. In is the source. So source 1. Input is the source. So we take the inverted source 1 as our input. Our control voltage is this mess. And then our output comes over here. Okay, cool. I think that's that. Now, if both 2 and 3 are 0, send 0. The question is, are we already doing that as a side effect of this first one? If 2 is 0, then that will be 0. If 2 is 0 and 3 is 0, then this will be 0. Input 1 will be 0. 0, 0, 0, minus 0. I think that's covered already, so I think we can actually get rid of this third VCA. Let's try that. Yeah. Whew. That required a bit of thinking. That was a tricky one. Excellent work. Thank you. Can you hear the water flowing through the pump? That's the sound of life right there. Exciting times. Indeed. That was a tricky one. That was a huge difficulty bump. Alright, I think we got time for one more. Do irrigation distribution circuit. Now that the pump is working, you need to rebuild the distribution circuit. The circuit takes the water flow and distributes it to the different irrigation channels. So get started. Alright. Source 1 is an input signal. Source 2 and 3 are control signals for two separate VCAs that control the intensity of source 1. Okay, let's start there. Where's my VCAs? So take a VCA, source 2, source 3. Wait. If source 1's intensity is higher when controlled by source 2, what did I just say? These are control values. And we need a splitter. Source 1. Those go into the VCA. Okay. If source 1's intensity is higher when controlled by source 2, that's this guy, send source 1 controlled by source 2 to out 1. Okay, let me think about that. What is that saying? That's saying, it's basically saying if this signal is higher, send this signal. Otherwise, send that signal. So... well, that's easy, right? We just pump these into a max. Right? If source 1's intensity, source 1 is an input signal, source 2 and 3 are control signals that control the intensity of source 1. If source 1's intensity is higher when controlled by source 2, send source 1 controlled by source 2. Otherwise, send source 1 controlled by source 3. I think this is it. I think this is a very easy one. Okay. Is that because the last one was so hard, they took pity and decided to make this one super easy? Good work. The irrigation system is nearly up and running. Alright, well, I guess we'll dig into one more then. I was expecting that to be a lot harder. Irrigation Controller. This is the last step for the irrigation system. This circuit is the central irrigation controller. It receives the signals from the main pump and the sensors and controls the water flow. Let's do it. Alright. When the signal from source 1 is more than 25, out 1 receives 100 volts. Otherwise, it receives 0 volts. Out 2 checks the value of source 1 signal after it has been decreased by 25 volts. If the signal is still more than 0, out 2 receives 100 volts. Otherwise, it receives source 1 decreased by 25 volts. That's weird. That's weird, right? When the signal from source 1 is more than 25, out 1 receives 100 volts. Okay. If the input signal is more than 0, this module outputs 0 volts, else it outputs 100 volts. So we can do this. What does our input signal look like? It's all over the place. So I think all we need to do is throw a bias. I'm probably going to need a splitter here, but we reduce the input by 25. So now, if the input signal is more than 0, so we're subtracting 25, and then saying if it's more than 0. So this is going to say if it's more than 25, we output 0. That's not quite what I want. I think I can use an OR. I think this is the trick. I think I do an OR with only one input. Because then the second input will always be 0, but we're driving off of the first one. So if there is any value coming out of here at all, if there is any positive value, right? Yes, if there's any positive value coming out of here at all, then we will output 100. Like that. Get rid of all this stuff. Okay, so that's the first part. Out 2 checks the value of source 1 signal after it has been decreased by 25 volts. If the signal is still more than 0, so if this value is more than 0, out 2 receives 100 volts. Otherwise, it receives the true value. Interesting. How do I do that? Otherwise, it receives source 1 decreased by 25 volts, which is this. So I think I need a splitter here. This goes, no, this goes here, this goes here. Because we're going to need to reuse this value. We're also going to want to reuse this value, so let's do another splitter. Let's do this like this. Like that. Okay. If this signal, so this covers all of the cases except this otherwise. how do I handle the otherwise case? So I think I put this in here, and then I say, and I put this in here. If the output is not greater than 0, if it is greater than 0, then it's going to take in 100 and it's going to take in some other amount. So this would not work if the input signal is greater than 125. This won't work. Because if it's greater than 125, is that right? Let's say it's 150. Let's say the input signal is 150. We're going to reduce it by 25, so now it's 125. This is going to work because it's greater than 0. So input 1 here will be 125, will be 100, because that's what this OR does. And input 2 will be 125, so this will output 125, which is wrong. Which is wrong. But if none of the inputs are that high, then we can beat the level even though it's wrong. And so now this is an interesting scenario, right? So here again, I will pose the question to you all. I think, and we will test this in a moment, I think if I hit play right now, this will work. But it's not a true solution, right? Because what's going to happen is, it says, if the signal after it has been reduced is still more than 0, receive 100 volts. This solution, if I'm correct, will work as long as the signal reduced by 25 is less than 100. If the input signal reduced by 25 is greater than 100, this will fail. But looking at this input signal, I don't think any of the inputs, there's one that is 100. I don't think any of these inputs are high enough to make this fail. So I leave the question to you. I think for this episode, we're going to go ahead and wrap up by playing this and seeing it succeed, hopefully. If you would like to see me rework this into an actual solution that always abides by the second condition, let me know in the comments and we can absolutely do that. So with that, let's try this out. Oh. Okay, I did a whole spiel. Turns out it may not have mattered because I have stuff wrong anyway. So what's going on here? Why did this fail? So we were fine up until here. When the signal... Okay, it looks like out 1 was working just fine. So out 2 does not work. This, I think, is a great chance to use this oscilloscope. Let's try this. We're going to pipe this into here. We're going to pipe this into here. And we're going to pipe this to here. Let's try that again. Oh. Okay, I can pause it. Okay. So we can see here. Ah. Yes. Okay, so the problem is it's taking the max, which in this case was 0, which is wrong. Stop playback first. Oh, yeah. Source. So, okay, so output 1 is working just fine. The trick is output 2. Output 2 checks the value of source 1 signal after it has been decreased by 25 volts. If it is more than 0, out receives 100. Otherwise, it receives source 1, decreased by 25 volts. I think I can do this. Because if this is more than 0, I think this is the trick. So what did I just do there? I said, if, so we know this OR says that if the input is greater than 0, and we're reduced by 25, so if source 1 is greater than 25, output 100 volts, right? If it's not greater than 25, output 0. Yeah, so in the scenario where this is still greater than 0, so if source 1 is greater than 25, this is going to output 0. So then we end up summing the 100 volts with 0 and we get 100 out. That's fine. So now we need the other case. If this is less than 0, which means that source 1 is less than 25. So if this is less than 0, what does not do? The input signal, if it is less than 0, this will output 100 volts, which we can use in a VCA. Here we go. This is the missing piece. Using a VCA along with this input signal and sum that to the output. Right? Make sense? So we're saying if source 1 is less than 25, if it's greater than 25, this will be 0. If it is less than 25, then we will take 100% of whatever remains, which is less than 25, and output that, and this will be 0. Let's try that. There you have it. That was a tricky one. That was a hard one. I enjoyed that one. March to the Sea, Sherman. Good. Things are starting to come together. What's the next step then? I'm sending you the specs now. Excellent. Well, that has been... So we got through quite a few there. We got through 5 levels, I think. Logic test, min-max test, irrigation system, irrigation distribution circuit, and irrigation controller. We have the whole irrigation system up and running. And next we move on to the radio broadcast system, but we will do that next time. So if you guys have enjoyed this, hit that like button, leave a comment, let me know. Like I said, so far it's hard to tell if the series isn't getting a lot of traction because you all aren't enjoying it, or because YouTube isn't pushing it through the algorithm because of how much shorter the episodes are. So this episode will change that and see how that goes, but leaving a comment, hitting that like button is the easiest way to tell me that yes, you are enjoying this, or no, you're not. Hit that dislike button if you're not. And then, like I said, if you are, cool, we'll do more of this. If you're not, we'll move on to something else. So I want to thank you all for watching, and I will see you next time.